Welcome back, everybody. I hope you had a chance to freshen up, get some coffee, snacks. It's day 2. We're kind of, getting towards the end of the sessions, but I hope you're still enjoying and taking a lot of wonderful things out of the conversations and sessions. I am super pleased to introduce or reintroduce Frank and Florian from Digital Frontiers. This is my absolute pleasure to be introducing them, I think, for second or third conference in a row, I think. Third one, yes, wonderful. They always have amazing things that they have discovered and are here to share with you. So I'm really excited about today's conversation because when anybody hears about event sourcing or event-driven architecture and what is that, events are immutable, we all get scared and like shaky, right? Because what if changes happen? What if requirements change? What if we're working with government software and laws change, et cetera, et cetera? How do we deal with all of that? So I think they're here today to kind of make that a little bit of an easier conversation to have, hopefully, and show us the benefits, of course, and maybe some of the challenges that you've overcome. So I'm looking forward to it. So please help me welcome them on the stage, and thank you guys for being here.
Thank you. Ooh. So thanks for the introduction. It's always a pleasure being here, but actually the bar is now very high because of senses like we discovered such amazing stuff. Because actually whenever I'm here, so the last talk also was on day 2, and I realized on day 1 that basically all I wanted to say, someone had it in their talks already. So that means on one hand that is probably not completely wrong, but also you might see something that you already know. But that's still okay. So we're talking about hidden strengths of event sourcing. And actually, yesterday Martin asked me, "What's the title of your talk?" And I was like, "Hidden strength of event sourcing." And he looked at me, was like, "Come on, they're not that hidden." And he's right in the way. So if you're doing event sourcing all the times for years, there might not be a lot of new things for you. But what we wanted to do is basically, or let's put it another way, what we do in our daily work, we're consultants. We help customers with their digital transformation. We help them reach their goals. But the thing is, I'm not a consultant for event sourcing. Nobody calls me and says, "Hey, come here, do some event sourcing." Basically, a customer always says, "Hey, solve my problem." And when you tell them about event sourcing, they are usually like, "I don't know, do we really need this? We did it differently all the time. This is something new." So basically, the secret title of this talk is a consultant's guide of how to convince your customer they actually want event sourcing. And this is what we're talking about. And as I said, a lot of things have already been said in different presentations. So it was maybe an interesting idea to start with talking about ilities, but somehow Elliot already did this, and somehow now my joke that security should be renamed to security is also not very new, but still. Yeah, ilities. This is basically what we talk a lot about with customers, because they say we want to do digital transformations, we want to be set up for the future, we want to write software in a way that we can, that is battle-proof, that is future-proof, we can use it. We need extensibility, we need scalability. Scalability is usually the first one you talk about because there's the most blog posts out there about it. Since the microservice era, everyone wants scalability. We have testability, stability, so a lot of ilities, but one that gets talked about or let's say not enough in my opinion, is evolvability. Because basically to me what evolvability means, that we can tackle tomorrow's challenges on the foundations of what we did today. Also, we heard a lot about foundations yesterday. And evolvability is a thing that gets more and more important in our world today because markets are changing ever faster. We are living in a VUCA world. That's a term I only learned recently, but I think I live in that world for quite a while. So it's volatility, uncertainty, ambiguity, all of that basically. And to tackle this, we need to build systems that can adapt, that can evolve to the needs of tomorrow. And we think that event sourcing is a great way to do this. But the thing is, when we introduce event sourcing to a customer, so this slide is from one of our event sourcing 101 talks that we sometimes give, we basically tell them about this. So there's this building blocks. We have commands, events, we have the event store, we have read models, which is absolutely fine and correct on the technical side. We tell them, hey, there's immutability. Immutability is very, very useful. You do want that. You have your event store as the source of truth. Everything on the slide. So basically, I don't think this is new to anyone in the room, at least I'd hope so. But then again, immutability it makes them think like this system will not go forward. This will stay at the same point as it was in the beginning because data cannot change. To them, it feels like my data cannot change. So how am I going to tackle new things? And so basically, this talk has two parts. First of all, we have some of those hidden strengths, basically. So the things that you don't see at first glance when you don't know event sourcing, and seeing what you can do with it in terms of evolvability. And also, in the end, we're going to talk about some misconceptions that we tend to hear a lot, basically. So let's start with our first hidden strength and talk a bit about which characteristics of event sourcing support this evolvability. So this slide, actually, we had a talk that we gave here 3 years ago about event modeling. We're talking about there's a lot of collaborative modeling tools out there. Event storming is very known. Domain storytelling was on the rise back then. But we already saw back then that event modeling and event sourcing are a quite perfect fit, and so we're very outspoken advocates for it for years now. And I think in this room we all arrived at the conclusion that they really need to go hand in hand. And this is also something that I tell customers, because usually, of course, we're talking about code. They want to know, hey, how do we need to write our code for the future? How do we add new technologies? Where are the new frameworks, the new technologies? But nobody wants to talk about how we do the requirements or the modeling differently, because they still want to write their big document with some use case diagrams, and you have to finish it in 2 years or something. But we think that event modeling and event sourcing need to go hand in hand, and using both, you can leverage an actual very big strength. So let's look at this event modeling blueprint, basically. This is from an example that we use very often. So it is about an online auction house. Probably we have not done as much online auctions as alerted bike rentals, but still it's our go-to example. And we have, so you probably noticed, yeah, we have events, we have commands, we have the views, blah, blah, blah. So this is an event modeling canvas. But now what customers tend to think is the next step. So we tell them, hey, do a modeling session. You need to get all knowledge out of your people's heads onto this blueprint. And then the blueprint is a very valuable artifact. And they go, right, so I have this blueprint, and the next step is that I draw UML diagrams. And I think that's not really bad. Or let's say it's understandable why they think that, let's put it that way, because we've done it like that for really quite some time. And so I actually, because we don't have any AI in the talk, I let AI generate this image for me. And if you look closely, it also looks like you do UML diagrams when you're at university, because there's an auction with a start and an end method, and I think nobody ever did it this way. There's of course an auction service, which is a singleton. An applicant recently told me that in his 20 years of experience, singleton is probably the only pattern from the Gang of Four book that anyone remembers, and surely the only one he has ever seen implemented. And we have something like this, and it's totally natural for them that a requirement that you found out has to be translated to UML so developers can implement it. That's what it always has been. And now that's the point where you can basically tell them, no, let's have a close look at our event sourcing blueprint, and let's have a close look at generative approaches like the one from Martin, like the event modeling notation. I don't know if you had heard the talk yesterday, but it's a really cool idea to basically have a standardized language for event sourcing so you can generate code out of it. And then suddenly, if you start with this event, you can directly translate it to code. So if you look closely, I gotta admit this is not Axon code. Actually, we stole some of the slides from another talk, and some of our colleagues implemented a CQRS framework of their own, because we think when we want to be experts, we need to understand the mechanic actually. But it basically is exactly the same for Axon. So we have a command, and it implements it has the fields that we defined in the event here, in the command here, and you have a one-to-one relationship between what you model and what you code. And basically removing this level of indirection is a value of its own, because usually we have abstraction layer over abstraction layer over abstraction layer, and this is what takes us time. So let's say you want to add a new feature to your application, and you just edit the blueprint and bring in a new slice. With code generation tools, basically, there is no intermediate step. You don't need to go to your architect and say, hey, think about how this translates to UML, what new fields, what new classes do we need, but you can directly go from here to code. So the first hidden strength that we want to stress, and that we often have to stress with customers, is that the building blocks basically are treated as first-class citizens in code.
Yeah, and before I reveal the second hidden strength, I want to go back to, let's say, traditional architectures. Let's imagine we would have implemented our online auction house with a 3-layer architecture. So there's a presentation layer, there's a service layer, there's a persistence and infrastructure layer. And the concepts that we saw in the blueprint, for example, a seller and the auction or anything else, are kind of distributed all over those layers. So, for example, if we take the seller, we have a seller entity in the persistence layer. We have some seller domain class and some seller service in the service layer, and in the presentation layer we have some DTOs and stuff like that. So imagine we would need to change the seller. So there's, I don't know, a second address line or something like that. Then we would assume that we only need to change those green bubbles, right? But in reality, it looks more and more like this. So we need to change other places too that basically use those classes. So you end up in changing more than you think, or even worse, it costs you more time in changing that because it's so complex. If we look at such changes in event sourcing, so example, let's imagine we have some premium seller subscription in our auction house. I heard that eBay now offers something like you can send your item to them, they verify it if it's, I don't know, pure gold, and then they give you a certificate and send it to the guy who actually bought it, and he has a certificate and he's happy and so on. So let's imagine we want to build that too, and we want to build it in a way that it's a subscription model. So you pay a yearly fee, and then you basically have this functionality, this use case. Let's start with user registration. So since it's an online auction house, we need to have some user registration, and there comes a user registered event out of it. And one way to basically do this is to tell the command handler, hey, if the command itself includes a yes, please, I want to use the subscription flag, then you could end up with something like this. We say, okay, you have a second event which says, okay, additionally to this user registration, there's also a new subscription for that user. And in that way, everything which basically consumes that user registered event, every read model and so on, is basically being untouched. So you don't have to think about changing other code parts and so on, and you can just use the subscription started event for read models that actually care about the subscription event, but all your user management itself stays the same. So you don't are like an octopus and grab somewhere here in the code and there and there. So it's basically, it's very streamlined how data is processed in the system, and therefore also the changes are streamlined. And let's think about that we then need, of course, something like a renew subscription command and a renew subscription event. This is also, we can just plug it in the code. In the first place, nothing else gets changed. We just have those two classes and the command handler and event sourcing handler and so on. But nothing of the existing code needs to be changed to do that. So you don't have to integrate with things you don't want to integrate with. So basically, the second hidden strength is we have well-defined interfaces and boundaries. So basically, you can think if you imagine the onion architecture or ports and adapters, this is something like there's this core and there are ports and adapters, and you basically have something like this with events and commands, and you basically can modularize your domain logic and and have it somewhere else as your infrastructure. So these are two different parts of your application, and you decide which parts of those two layers basically talk to each other and which do not.
All right. So let's go on to our third hidden strength, and we want to talk about testing a bit. So the blueprint, if you look at it, it doesn't say a lot about testing, but testing is an important thing because it's what actually makes our application, or that guarantees that our application is working as intended. So of course there is another part to event modeling that we left out, and it's this one right here. So we have this given when then specifications that basically tell us, okay, the correct behavior that we want in our application is that only if a shipment was received and the payment was also received, we are able to finalize the auction. So when this command comes in, then the auction needs to be finalized. So already, again, looking back at the old world, basically, or let's first look at the new world, sorry. How do we implement this now in a event sourcing text? Well, basically it's always the exact same thing that we see on the right. So we know our givens, we know our whens, we know our thens. So basically we have the possibility in code to say, hey, these two events have happened, and now when this third event, this command comes in, we expect that the third event is actually produced. So this is again the one-to-one translation that I previously mentioned. You do model things like you want them to be in code. And this is very interesting because basically what we get a lot today is that developers say, or let's also say managers say, my developers don't like testing. And I think that is an okay thing to say because testing is often not fun. But I think maybe the reason for this is the way that we are doing tests today, or did tests in the old world. Let's say we are a step ahead, but a lot of people aren't. So let's look how tests used to look. So I already said that we probably have some auction service in this here. And now the first thing you have to do is, of course, mocking, because my auction service is somehow using a shipment repository, a payment repository. So we need to mock those repositories. We need to mock the behavior. So this is all a lot about behavior, not about state. And that's what we had to do for testing in the past always. Then we would, of course, do some assertions, maybe say or check that the services have been called in the right way. So this is a lot of boilerplate that we have to write to basically say, hey, if those two things have happened, this third thing should be successful. And talking about evolvability, usually it does not stay that way. So let's say there's a new requirement in our system where we basically say, okay, an auction can only be finalized when a seller has given a rating for the buyer. Nice eBayer, 5 of 5, would buy again, whatever. So if we want to do that test in the traditional architecture, there's probably suddenly a third repository involved, some kind of review repository. We have to check, is there already a review? We have to mock this behavior. We have a bigger constructor, and that's exactly the same thing that we heard about in our hidden strength number 2. So let's say this is a place where we actually want to test this finalization thing, and that's what we need the review repository for. But in every place in the application or in the test suite, let's say, where we do something with the auction service, suddenly we have to touch that test and also at the review repository because of the new requirement. So we're going to touch, I don't know, tens to hundreds of locations only for a feature that should be in one place. More assertions, more verifications, blah, blah, blah. This is not very fun. This is time consuming. This is probably error prone. And I understand why users say this, or why developers say this is not fun, I don't want to do this. Actually, I recently tried to mock access to an AWS DynamoDB, which uses some static constructors and nested stuff, and actually I couldn't do it. It was not possible, actually. I just encapsulated somewhere else and mocked that interface. But yeah, there's mocking is not fun, and mocking does not play a role at all in our tests for event source systems, because basically what we do here is we say, hey, there's a third new event, a buyer rating submitted event, and now our expectation is after these 3 events, everything is fine. And on the opposite, coming back to our old test, if only those 2 events are there, something should fail. So we can basically bring in the natural language and the specification from the blueprint that we had in the first step over to the code super easily. Maybe with code generation probably. So there's several approaches that are on a very good way to that. So I'm pretty sure that this this hurdle of I don't want to write tests, it's so much effort, will only lower in the future in event source systems, and this will gonna give them an advantage over time. So basically, the headline testability is a hidden strength of event sourcing might not be very creative, let's say, but the ease of writing tests, the possibility of writing automated tests, and what we saw, the evolvability in testing basically, gives event sourcing a huge advantage over traditional approaches.
We have one hidden strength left, but at first, as Flo already mentioned, we're living in let's say, in a world where software is always evolving. So we use iterative approaches to form MVPs, to get something running, to show a possible customer that we can create a value with that software. And if he's convinced, he says, yeah, okay, this is fine, but I want this, I want that. And so we need to prioritize new features, write tickets, and so on. And out of this feedback, we need to adapt the software, and basically we do that again iteratively. So basically, this is the loop we're living in, and this is sometimes not compatible with a state-based persistence, right? If we take another example of our auction house, we say we want special badges for users that have been registered for 5 years, because it's gamification and this is fun and everybody needs that. In traditional architectures or in state-based persistence, this is the UML diagram Flo showed earlier. We don't have currently the registration date of a user, right? So we basically cannot fulfill that requirement right now. So we would need to change the user class to something like this, where we have added some user registration date. The downside of that is, if I introduce this registration date today, I can start issuing badges in 5 years. This is not really what we want, right? So in state-based persistence, you cannot build something on information which you had at the time where this date was written to the database, but then you just said, okay, I don't need it, I throw it away. Let's have a look at event source systems. We have this user registered event which contains by chance some metadata, especially the timestamp where this event was actually issued. So currently in the user's registered event, this is fed into the user's read model, and currently this is not in there, right? But we can now easily adapt the software. Okay. The user in the read model contains these things, the user ID and the email. But as I said, we can easily adapt the software by adding another read model and just replaying all of our user registered events into that users with badges read model. And bam, once this replaying is done, we're basically able to go live with that feature today, not in 5 years. And we can also, let's say, not only apply that mechanism to existing read models, we can also add new read models by that, and therefore support new use cases. So basically, if you imagine we have a browser which accesses a read model for the web. This is a copy-paste error. There should be event 1, event 2, event 3. It basically doesn't matter. It's just we have a read model which is optimized for a browser version of our software. But if I want now to basically support a mobile version of my software, then I possibly have other requirements to that read model. I need a optimized version of my data structure for the web. And basically I can do the same exact thing as I did before. I can just add another read model, replay all of those things into there, and then ta-da, I'm done. I can support my new use case. So this is also pretty interesting in terms of architectural evolvability. I can just mesh up some data I already have, and then I can basically provide, we call it day one data features. So you can basically implement features that access all your data which you had since day one, and you don't are depending on data you start capturing now. Yeah, so this was our part of the hidden strengths, and I will now pass on to Flo for misconceptions about event sourcing.
Exactly. So as I said in the beginning, those hidden strengths, or as Martin also guessed from the beginning, they are not so hidden. They're probably not very hidden to a lot of you, but the thing is that so let's put it that way. I don't make any assumptions anymore about the audience on this conference, because I think it's very amazing that you really have all the skill levels here. So last year we got to know some guys from a company. Basically, before attending the conference, they heard about Axon. Someone told them, you should use Axon, and that was exactly what they did so far. And they went to the conference and were like, what is all this Axon stuff? So I don't know if someone like that is in the room, but then again, I think all of us in here talk about event sourcing with other people regularly. And the more we do it and the more obvious it becomes to us, the more we tend to forget that other people might not be there. So it's not only a consultant thing, but I know there's also some consultants in here, but I think all of us will have this discussion from time to time. Let's assume a new member is joining your team. Let's assume you have to convince your boss that Axon is the right choice and he should not prolong this super expensive Oracle license, whatever. I think we have this discussions all the time, and all of us do, and I think it helps to let's say think about this way and how can you put it. And the same is for misconceptions. So as I said, we tend to see those a lot. I even see some of those with people that are already using event sourcing today. So customers that use Axon in their systems and do event sourcing all the time. Some of the people there did not grasp those concepts. So let's talk about these misconceptions that we tend to face a lot. And the first one was already teasered in the moderation, that immutability and evolvability seem like let's say contradicting words, because basically when you say something is immutable, a lot of people understand it is like this, it will never change, and you have to deal with this in the future, and it sounds more like a liability actually. I mean, we have mechanisms that tackle this, but people tend to not know, so they say, but yeah, so I have this user registered event, so luckily in Axon we automatically know the timestamp of an event, so we can make use of that. But let's assume our example from just now would be something else. We really don't have the data in our old events. So hopefully we have all the data and can implement it as a day one feature, but even if we don't, it might always be that we say, hey, we made up more data that we need to change this, and we need more stuff in our events. And people come to me and say, how does this work with immutability? Because they just don't know the concept of upcasting. And when we tell them, well, you can do some upcasting, you can take your old events, do some transformation, and basically make them conform to a new format, they still tend to think that's somehow overly complex, and why would you even do this? And the thing that I usually tell them then is, how is this different from adding a new table to your a new column to your database table? Because basically they know that they do this all the time. It's a great thing. They have to take down the database for 3 hours. It's maintenance on a Saturday. Everybody will have a great weekend, and this is somehow fine and accepted. But telling them that this upcasting mechanism exists, basically they're like, That sounds a bit fiddly to me. So this is really something that we often hear, and where you basically need to have your arguments ready and tell them it's no different from what you've done all the time. It's just the same concept in our new modern world. So this is one of the first, and they are roughly ordered in how often we tend to hear them. This is the first misconception that we face really often, and I think it's an easy one to counter, basically. And the second one is something that I really like. Eventual consistency is not suitable for user-facing systems. And I actually, of course, knew what I wanted to say for this slide, but then 3 days ago, Martin Dilgo posted something on LinkedIn where he quoted Adam with the wonderful sentence, eventual consistency is a non-issue. And I think this is perfect wording for it, because basically, of course, users tend to come from a CRUD, from a state-based world where you have transactions, and if you want to input some data and you hit the save button, you wait until your database tells you, okay, everything has been persisted, and then you show the user the result and say, here's your result. And for some reason, product managers, UX designers, whoever cannot snap out of the imagination that this is the way it has to be. Because you can tackle this in such an easy way. You can just save it, tell the user your data has been saved, and let all the other stuff catch up in the background. Take them, redirect them to another page where they don't see the immediate results, whatever. There's a lot of mechanisms that you can tackle UX-wise that can deal with this problem. Of course, you can, if it's absolutely necessary, also use mechanisms that provide some sort of artificial synchronicity. If there's no alternative, you can always do that. Event source systems don't forbid you to do this, but I think if we just think about UX in a different way, this is something that should actually really be a non-issue.
The next one is CQRS is only about supporting analytics, and there are cheaper ways to do this. You can simply use another relational database and do your counting of your registrations or your things that you're basically interested in. And for some reason, CQRS and event sourcing are tied up to this analytics use case. Or what is basically what I hear basically not more often, but at the same level, is you only need CQRS when you have scalability problems. And I think both of them are wrong. So CQRS, in my opinion, stands for flexibility, as you can, of course, CQRS and event sourcing stand for flexibility, as you can just pull up new read models, new use cases, and use your old data. This is what one of our hidden strengths also showed us. It's not about only scalability and analytics use cases. The fourth misconception is that event sourcing and GDPR are incompatible, because you have those immutable events that you cannot change anymore. And there are ways to tackle that. GDPR is challenging, I guess, for every IT system, because also in a CRUD world you need some way to deal with it. But in event sourcing, it's just another set of patterns. Maybe in the CRUD-based world, you would go in your database and just delete some rows, and then you're happy. I don't know if I would actually do that in my real production system, because then otherwise some kind of other consistency in my data gets violated and so on. But this is another story. In event sourcing, you can do simple things like you can either encrypt your events and say, okay, if Frank wants his data to be deleted, you just throw away the key. Or you can do something like, if there is PII in your events, you just say, okay, there's an external data store which actually contains those PII, and you can basically take the ID of that and write that into your events. And basically, if I say, okay, please delete my data, you just delete my PII from the from the external data store. This way, you can preserve your the whole information which is basically in your system. You know how many users you had at which point in time. You know how many auctions per month or something like that have been happening in your system, because you still have that information. You might not have the information who actually was participating in that auction, but you know that there was some auction, and yeah. So basically, this is not hindering each other. You just have to apply other patterns than in the CRUD-based world. And the fifth one, as Flo said, we ordered them by probability of hearing them. I tend to hear them not that much as I heard them once, but I still want to point out that I'm using Kafka, so I do event sourcing, and event-driven architecture is plain wrong. If you do Kafka, you might do event-driven architecture, but you might do something else. If you do event-driven architecture, you can use the events in your Kafka to basically enable communication within your system between services, but this is not event sourcing. I don't know how this misconception got into the world, but just so to say, if you use Kafka, you don't do event sourcing. Event sourcing is something that happens in your service. Event-driven architecture is something that happens between your services, and Kafka is a tool to basically enable the communication between your services.
I think I can answer where it comes from, and it's the Kafka marketing department.
I think they should have done a better job by promoting his books, but this is another topic. So, to conclude, event sourcing has many, many valuable properties like immutability, and you have one single source of truth, and so on. All of the things which we've seen on this event sourcing 101 slide. But it also provides some very valuable characteristics to architecture itself, to evolvability of the architecture. You have building blocks which are as first-class citizens in your code, so you don't need to pull out some UML and some BPMN of your code and then say, okay, how do you actually map that to your domain language or your event modeling and so on? No, it's just a one-to-one mapping of things in your code to your blueprint, and this is fine. You have well-defined interfaces and boundaries for the actual domain code, so you only need to change things you really want to change when you are evolving your software. You have isolated tests, you have more readable tests, so you don't have a scenario where you might have a piece of code which tests something, and then this something gets altered, and you write another test for that alteration, and basically by doing that you would influence your first test. You don't have that. Those tests are in 90% of the cases more isolated than in a CRUD world, and you have this day one data feature support where you can basically mesh up your data, and using that you can support any use case with the data you had from day one when you started your software. And knowing these hidden strengths, we think at least, helps you to demystify some of those misconceptions. And that's it.
Thank you so much, guys. Thank you so much. This was amazing. I think this should be, who thinks this should be a blog post or an article or at least a LinkedIn post? I think this is really valuable. So please jot it down and send it to all of us. We have about 5 minutes, so anybody has any questions for Flo, Frank? Yes. Sorry, that was first.
Thank you. I have a question for the testability phase. I see that it's increasing the readability, but does this have any cons with it, like performance hit? I'm asking this because I remember Spring also has this kind of declarative test for mock embassy framework, and they also, I mean, it's very good actually, but their startup times are usually higher, and they also tend to use more resources. So in your suggestion, when we write the test in a more readable way, is there any performance hit, and if so, how are you planning to solve it?
I would not say that it's it has a negative performance impact, because basically it's not really, let's say it's not really up to discussion. It's just how you test an event source system. So you have these capabilities of using a fixture with the already happened events and then calling the command handler. Axon comes with all of that, and it's how you should test. So it's just it's more of a paradigm shift. So when you want to test your Axon system, your event source system, it's basically not, you don't start and say, yeah, maybe I do some mocking and call some services. We just don't have that. So it's a completely different approach, and I could not make out that this approach is significantly slower. It might even be faster, because you don't have to bootstrap a lot of mocked stuff and surroundings, basically, because it's all based on events that happen in a command handler.
I think there was another question up here.
Yeah, I just wanted to add something to your misconception about Kafka. It's near and dear to my heart. I did work for Confluent, so there is really the misconception that Kafka is an event store, which it is not. Actually, if you have ever read the paper of Pat Talent, where he describes data on the outside versus data on the inside, Kafka is for the data on the outside, which you rightfully identified is between services. It's also not the service bus, but it's for transporting data at high volume and low latencies. And event sourcing is about the data inside the thing, whatever it is. And now to correct this misconception that it comes from the marketing department of Kafka. First of all, there is no marketing, it's an Apache open source thing. Yes, Confluent has the most committers for it, but I was personally involved to demystify this thing, that it is actually not an event store. Just wanted to say that.
All right.
Sorry.
I think that also deserves a blog post. Any other questions before we take our break? Awesome. Thank you so much, guys. Really appreciate it. And yeah.
Thank you.
Thank you.